Right, today's video we are going to be doing another 4G antenna. It's the same thing, but we're going to change a few bits. So the idea is you're going to have our central rod that goes through, and on our previous one we had the back disc, and then we had a slightly smaller disc, so we had our reflector. That's an F. The actual inner part of the antenna is that one, and then we had a slightly smaller disc again, and 1, 2, 3 slightly smaller collector discs. Now these were spaced this is 10mm between the discs, so between there and there, and the next one was 9mm, so put that 9. Then these ones are at 33mm between the discs, so between there and there, there and there, and there and there. 10. The diameter, also the diameter of the disc, so the measuring from there, was it radius, I don't know, the distance between there, we had, that was 100. This one was 74, this one was 54, and these ones were all 33. So, and we had one big one, one smaller one, and 3 33mm discs. So we're going to go, so what we're going to do today is we're going to go 3, 4, 5, 6, 7. So we're going to add a fair few more collectors. 1 extra 4 more collectors. What this is going to do is apparently it's going to increase the gain of the antenna, because this is a directional antenna, you'd call it. The more collectors you put, the more focused the antenna beam is. Now, the thing we were talking about in the last couple of videos is where the isolation points of the antenna are. So you have the big disc, the slightly smaller disc, smaller disc again, and the collectors, like so. So our coax wire has got to come in. So you know what a coax is, it's a wire like that, which is a wire. Then you have a step down inside, and this is where the screening braid is on it. So you have the screen, and then inside there is the actual inner conductor. So what we've got to do, this screening braid, after the few attempts, the best way I worked out is it's going to come in, the screen is going to attach to the first one, screen, and the inner conductor needs to connect to the second disc. So the screen will be connected there, and the inner conductor needs to connect to that one, the second disc. And with the best results I've found, this disc has to be electrically isolated from the rest of the antenna. So the screen connects to this first disc, which connects to the threaded rod with all the nuts on it. But on this one, we need to actually drill the hole slightly larger. So I'll show you how we get around, how we do that in a second. Where are we over here? So yeah, the hole inside this one has to be drilled larger, so it doesn't, the actual copper disc does not come into contact with the rod. So the actual inner pole of the coax has no electrical connection to the screen in any way. So zoom you out a bit. So annoyingly, it does take a while to do, but I've gone through and ordered the sheet copper, gone through the tedious process of drawing the circles using a compass, where you measure it with your verniers, which I still haven't brought out with me, but we should be in the round of 100, which we are. It's very reflective and annoying, but yes, 100, just believe me. So, what did we say? Just so we know, because we've got to obviously drill the holes in the middle of these. So the big one was 100, and that is from there to there, not to the centre, just to the outer. So 100, 74, and a 54 and 33. That's that many 33. So there's all our collectors this time. 1, 2, 3, 4, 5, 6, 7. Marvellous. So I need to centre punch the inside of all of these, drill the hole. The only difference is the hole for this one needs to be the larger one, and then we're going to use these plastic washers, and beside the larger hole we put something in there to stop the copper disc from conducting onto the threaded bar. We have another 3 lengths of threaded bar. This time I've gone for 500mm, just because obviously it was going to be a bit longer. Get this out of here. There we are, nice bit of threaded bar. So let's draw some holes and let's go from there. Easy as this. Got the mark that I used to make the centre already on there. Onto a block of wood. On my mark. Let's make sure it's something nice and flat. Little dink. Ooh, that might have been a bit too hard, but it's in the middle. Drill's not going to wander. I'm just going to get a bit less on this one. Yep. Now, you can see the discs, they look a bit ragged and not perfectly round, and you'd be right, because it sucks cutting in copper. Just like cutting copper, it doesn't like being cut with conventional cutting tools or saws or anything. It doesn't even like being drilled. This one's got a bit of a bend in it, which I'll straighten out later. So yeah. The next bit we've got fun with is we've got to drill holes. Now what I forgot to do, a top tip for next time, when you've got your copper sheet, and the easiest way of marking your circles out is to say you want to, let's go 30, it's just to set the end of that, and then you can scribe round and make a line. But for God's sakes, before you cut the circles out, find your centres, do that and drill them first. It's much easier to hold on to this than it's going to be for me now to have to hold on to this. Anyway, on we go. Two more to do. We'll split that up with a bit of chatter. And the final one. Perfect. Slightly oversized hammer for the job, but it's not the best. Alright, now we'll drill these. I'm going to do this in a vise, because, yeah, these are going to wander off and cause me the same mess with making this. One. I'm just going to make this slightly easier. Process up. Now because I'm doing this, because it's only 0.5mm copper sheet, shows it because it's just easy to cut. Skip along onto the 33. Just piloting them first, and put a bigger drill through in a minute. You can whip one of these up pretty quick. Lost one, I think. Yes. Right, change drill size. 8mm, apart from the one that needs to be bigger. So I'll move him aside. There. Copper drills so horribly. There's more that rips it to pieces than actually cuts it. See, it does not focus. Doesn't cut very nice. That's point focus. Anyway, yeah, so I mean, just rips it. It is what it is. We can live with that. Copper's soft, it's washed down. Not too bothered. Also, of course, all the drill batteries are flat, so we're working with a drill that doesn't have much charge. Hoping it'll make it to the end of this job. And a few more to go, and it's not like we're working it very hard. Do that one. This is the last one that we need to do. Totally light. 50 quarts at 100. Done at 8. And the 74 going for a 12mm. Right, next thing on our diagram was the cartridges would enter the disc 11mm from the edge. Just there, in 2 places, so quite a bit there, 90 degrees there. Get it in the right place. Be able to see. So there and there. 90 degrees out across there. 11mm from the edge. Drill through that. That's also going to drill through the 100mm disc. So if we drill them back at the same time, I'll go through. I'm going to be using these again. Right, if you remember these from last time, they are coax SMA male female connectors, but the this end's got a bulkhead fitting. So last time we used a 6.5mm drill bit to make holes for these, and I've marked out 11mm from the centre of this disc at 90 degrees. So we've got the place to put both of these through. Well, they come through this way, but you get the idea. So, go for that. Right, we've got to this stage. I've bolted the reflector on in its place. The next disc with the actual coax centres connected is actually called the driven element, which I now know. So what I've done, these 2 discs, this one's obviously the one the coax is going to connect to the shielding. So what we've actually got to do is make this one electrically separated from the rear reflector, so the driven element cannot contact this rod, and the many director discs will be connected to the rod, which is also connected to the shielding. So what I'm going to do is I'm going to use a piece of, it's a 10mm airline, this airline tube. I've cut it to the right width to fit in between two plastic washers, which best is to use M12 if you can do this with M8 rod. These are M10, but I've had to drill them out because I didn't have M12. So to get my correct dimension from this disc to this disc, which is 10mm, I'm going to first chuck on my first washer. That's going to go down, you see it, to there. Slide on my bit of airline, which will isolate the disc from the rest. You can just about see that. And these washers will fit over that piece of tube. As you can see there, it's actually fitted over it. My disc is going to drop on the driven element. That fits over the airline, and then another plastic washer, which then gives us electrical separation. So for the next one we need 10mm, so I'm going to actually chuck a washer on there, a steel washer, whatever, it's stainless. Tighten that down, bring that down, and that's what's going to give us our separation. So, and that should work out at 10mm, which is pretty much bang on. So before I bolt that together, I'm better off getting my two coax bulkheads through this plate and bolted up. So I've already threaded a nut on here, so that's going to have to come off. And this is the bit where we're still going to need the blowtorch in a minute, because copper discs don't like things being soldered to them. So I've got two coax connectors, the bulkheads, get the nuts off. I decided two M6 washers. I'll do two the same. There we go. Two 1mm M6 washers through there. Means that when these are put through there, they don't want to fit. They will go through there. Then the next disc, when it's in here, isn't going to contact the outer casing. So we put our little crinkle washer on. That can go on. Blow that up tight. Now the other issues we're going to come across with this being outside is that we've got so many dissimilar metals, we're going to get a bit of galvanic reaction, but I'm not too worried. Just keeps working. There's one. Second one. I'm going to find another M6 washer. Use three washers because they're a lot thinner this time, because I ain't got the same type. Three of them. Two thin ones and a thick one. Doesn't matter. That one can go in there. That one fits better. Crinkle washer. These SMA male to female leads are easily available with these little bulkhead type fittings, and to be honest, that seems to be the best way of doing it. They come in 5 meters. I don't think going above 5 meters is a good idea. It's just too much signal loss on the cable, actually, because the cable they give you isn't generally very good. There it is, they've got it through, you can see that now. So now we can put our second disc on, which is the 74 disc. Still got all our isolators there. Two holes should line up with the coaxes, same coming into view, so there. Another isolating washer, a plastic, a big washer, and a nut. Right, tighten that down. I'm actually going to get this disc to stay in the right place. Show you the thinnest spanner we've got. Can still fit in there, perfect. This one I'm going to use to tighten it. And that's all in line. My spanner now belongs to the antenna. Yeah, that's good, we're away. So we're at this stage, we need to put our wires that are going to lead into the centre of the coaxes. Let's just see if we can get in that close. The coax centres are in there. So I'm planning on using a diode just for its wire. Poke that in the centre. So I'm just going to lead off to the side. That's the way I'm going to do it. Then I'm going to solder this wire on. Hopefully. Cutting back there. Be perfect. Same again for this one. And what we're going to do is we're going to solder those. There they are. We're going to solder those. Then we're going to tweak the disc round ever so slightly, just a tiny bit, to make sure that these are making good contact in the centre of those coaxes. So yeah, let's get them soldered on. That's annoying. We have to deal with how reflective copper is. Is that good? Yeah, we're good there. So last time I was trying to use a soldering iron to do this, which wasn't working. I think we can just do it with the blowtorch, to be honest. Here we go, see if it's going to work. And what you don't want to do is what I've done, which was I've just melted my copper washer. Never mind, should be alright. Get it cooled down before it melts too much. Yeah, that's better. Yeah, maybe get a bit more gentle on the heat. But as I just explained, now I've done that, hopefully everything's not red hot still. Now it's cold. So I'm just going to tweak this disc round. So those wires are now bent ever so slightly into the coax. All that's left to do is I'm going to make a quick check with the meter. No connection. Good. If we have a look at the other ends, so outer casing, yes. Inner, no. I check the inner for continuity if I can manage. It's a bit tricky. Yeah. So I'm quite happy with that. We haven't made contact on either of the wires. Good. So I didn't melt it too much. If you don't melt it too much, you're doing alright. So the next bit needs to be 9mm away from this disc, and I set our verniers to 9mm. Is it 9? There's my technical drawing. Technical drawing states 10, 9, then we just go 33. Right. So that's going to get us almost bang on. So our next disc is our 54. Disc 54. All the way on. I'm going to run nuts all the way down. I will not make you sit here and watch me thread a nut all the way down. Is it cheating if it speeds the job up? No, it's not. So we check again. Should be at somewhere near 9mm. Pretty good. My disc's a little bit bent, but that's about 9mm. And everywhere from here it is 33 till we run out of discs. Right, so let's get on with that. I tried using an airline, but this will probably actually work better the other way. And we're out of battery. I had a feeling that would be the case. Never mind. So we're going to set our verniers to 33mm. See where we are. A bit to go yet. but it's much easier as we get further down, because we haven't got to find washers that use as spacers. We just got to use the nuts. There we are, that's about 33 there. Perfect. So we grab another 33, well, the first 33 of 7, and we go to town. This is obviously going to take me a long time to do, so I'm going to spare you watching me put 7 discs on at 33. And we cut to the end. If you haven't got a drill, but you are wearing a jumper, just roll it down your arm. Helps if you keep the fabric straight and get it quicker. That's much easier than doing it the other way. So here's what we come up with. Now I've got a bit of an excess length of threaded rod, I'll probably just cut that off. But yeah, so this one the dimensions we've used is for 2100 megahertz, which is 4G in the UK in rural areas, not in the whole country. In more built up towns you go to, I think it's 1800 megahertz is what they use. I'm pretty sure anyway, I can't totally remember. But this, I'm out in the countryside. I'm about good 4 or 5 miles away from the 4G antenna. That's actually giving me my signal. So that's the reason why we're doing this. And I'll call it the Oggy Gaming version 3, because Oggy Gaming is the one who keeps telling me to change this, change that, try adding more discs. And everything he said has worked so far. So I'm going to take this, plug it into the router. Well, we'll try the current antenna, and we're going to put this one out and we're going to try it. We're not going for more download speed, because at the moment download speed, so we've been getting the download of 100 megabits per second. This is all upside down for you now. And the upload has been about, we've seen up to 21 megabits. I missed a P out there. So yeah, what we're hoping is, I'm not sure the download's ever going to improve. I'm not sure if the rural 4G network can go faster than that, but the upload, we'll see if we can get some more, because by initially isolating this disc, the driven unit as it's actually referred to, from the rest of the antenna, we were able to then get the 21 megabits that we're getting with the current antenna. Then Oggy Gaming said his antenna he's built has more of these they call directed discs. He's got 7, and he's getting better signal with 7, and these are just allowing the beam to be formed into more of a straight line. This means the antenna is going to be more directional, so I've got to get it more on point as to where the antenna is, but it also means it should get a stronger gain, a stronger signal. So let's try it. Right, so I'm just doing a speed test of the old antenna, and we've just got 160 megabits. I'm only getting 858 up. Let's get this out of the light. Right, so yeah, the current antenna, which has been working brilliantly, yeah, we're getting good-ish upload, but not as good as we just suddenly got download. I've never seen the download that fast. So yeah, the current one sits up here. It's just wedged in the gutter. It's not the ideal location, but it is what it is. So we get our new antenna, get that hooked up. Currently sat on the floor, and we're going to see if we can get the 5th bar of signal to illuminate. So here we go. Right, so on our first test of the new antenna, we're getting up pretty good, but we're not doing well for the upload. So what we're going to do, I'm going to mess around with the angle, see what we can make it any better. Right, give me a few minutes. Alright, so we're doing a bit more messing about with it. Got 4 or 5 bars, so I think we were, oh, just dropped down again. I think we're actually currently being limited by the actual how busy the network is being. It's half, that's 550, it's 10 to 6. So let's give it one more go. I mean, there's only so much you're going to get at this time of night. If we try it again, let's say midnight, when less people are using it, might see some even better, even greater benefits. I mean, the download speed's absolutely flying along, which means the connection's got to be good, but I think we're getting hammered a bit due to time of day. That, and there's loads of people staying on site at the moment, so they're all, if any of them are on E8, we're all trying to use the same transmitter, so we'll try it later. So far, should be good. Right, so we have a minor update. I've just had a look on a cell info light. I'm going to connect on band 3 at the moment, which means I've got my antenna wrong. I've put the wrong disc sizes, possibly the wrong disc size and the wrong spacing. Ah, joy. So, band 3. So the problem I'm facing is I've used this schematics. I believed that we were on 2100 megahertz here, but we're in my area. I'm actually looking through on the this website. I'm using band 3, which is actually 1800 megahertz, which is what my phone's telling me. If we go back on here and bring up the map where we are, I'm using this antenna over here, or one of these two. This antenna, which is pointing towards where I am. That is band 3 and 20. So I've got it wrong, but luckily I've got this one, which is pretty much the same, but I need to make my disc sizes different, which is annoying for 1800 megahertz, because I'm going to have to start again. Oh well, it is what it is. So there's going to be a part 4 of the antenna video, and I'm going to have to get more copper sheet because I haven't got enough, and we're going to try again. But I'm still going to throw in a test at the end of this video when the network's a bit quieter, but I assume that's probably why I can't get any internet speed any faster. So we're getting there. Next time, right, going for a final speed test. It is about 20 past 8 in the evening, so see what happens. Yeah, see, we're just not getting it at the moment. Mind you, we're doing that on the other antenna. But knowing now that I'm using the wrong disc sizes, yeah, well, there we go.